plugins as well. So that's what I want you to do with the Video for Linux plugin as well. Right, what do I need to do that zero copy here? First, there already was a DMA buffer memory and allocator, but yeah, it wasn't quite complete. There are a few bugs there, a few things missing, but nothing terrible big, so fix that. I think all of my patches there are actually in mainline already. The next part, I need to actually use the allocator and create buffers with that on, in this case, in our example, in the camera, right? So I need to teach the buffer pool to create these DMA buffer memories. That works already, basically, for me. But I need to use a small kernel patch, because so far the DMA buffer memory can only map read-only, which is okay mostly for cameras, because yeah, you don't want to change the frame unless you want to write a subtitle on it, maybe. But if you think about output, or for the man-to-man devices, the output side, you need to be able to write there to the memory. The patch was actually, I think, accepted for Linux mainline in the beginning of this week, so I think 3.13 will have it. So that problem is solved as well. So Video for Linux can produce DMA buffers, or memory, and it buffers with that memory in there. That's the easy part, actually. We can discuss whether we should do that by default or not, if it's possible. But anyway, this is pretty straightforward and a relatively simple patch. Using the buffers without copying is more difficult. The problem is that the code in the Video for Linux plugin in the buffer pool is not really designed to handle foreign buffers. So if you're not careful, it still tries to allocate own buffers, which fails, because we can't allocate buffers when we're using DMA buff. And all kind of things like this. So while I do have an ugly hack there, it's ugly. I'd like to fix it, and I think I know how. But if you listened to some of the things mentioned yesterday, I think there was just one bug reported about sharing memory and buffer pools and reference counting and things. Yeah, if I share the memory from the buffer and return the buffer to the pool, then the pool says, hey, I can reuse that buffer and queue it in the hardware, it gets filled, and the memory is still referenced somewhere else in the pipeline. Doesn't look nice. So that needs to be fixed first. And then I can actually share the memory and use buffers from my own pool. Instead of copying, I just share the memory from one buffer to the next instead. Same performance, no copying, and I don't need to handle foreign buffers there. But yeah, that's something that needs to be done and isn't ready yet. And the typical issues here, I mean, it works, so nobody pays me to fix it. So let's look at the performance now. Well, the red bar is a little bit there. It's actually really hard to measure what's left when it's 1% or 2%. I mean, yeah. And we have the full 30 frames per second, and basically GStreamer is mostly idle, doing nothing. The CPU is bored. That's how it should be. Yeah, I mean, but this is just one scalar here, and we want to do a lot more, if you remember this kind of thing. So it's not just putting camera, scaling, encoding, streaming, scaling a different size, encoding, and putting an image file or whatever. It's actually changing the pipeline what we want to do as well. Because, I mean, we don't want to stream in just one size, because depending on what the other side actually can receive, one might want to change that, or we want to switch off streaming because there's nobody listening, and we want to save that computing power, and especially in the hardware as well. It's a huge impact on the memory bandwidth to do scaling and encoding in H.264 for nothing, right? So we want to be able to remove parts of the pipeline live. Want to add pipeline parts. So if we think about image encoding, want a snapshot, there are 10 different sizes for snapshots. So you change one part, get a snapshot there, and then the pipeline, that part of the pipeline is idle until the next snapshot, things like that. For video recording, you add that part of the pipeline, encode, then remove it again. These kind of things require that we can actually change the pipeline live while it's still playing. The first code is probably half of the pipeline here. The lower part wasn't there. No decoding and no playback, basically. The USB stuff was missing. The recording stuff was missing. We just had the streaming plus snapshots. At the time, and that was still 0.10 because 11 wasn't ready, and, well, 1.0 wasn't released until, I think, another year or something. And it was, yeah. I think we've heard it before. Changing pipelines in 0.10 is try it and pray for the best. And that's what we had as well. Sometimes it worked, sometimes not. And when 0.11 was released, I switched pretty fast, and it was really great. So thanks for all those developers that got 0.11 and 1.x out there. It's really great. It works a lot better to do all these kind of things. And I think for my patches, for the plugins, I dropped half the code when I rewrote the plugins. So really good stuff there. Still, while it got a lot better, there are still things I need to fix, mostly actually not in GStreamer in the design that worked well, but in the plugin actually. So what was there? I mean, sometimes you need to allocate new buffers. If you think about the pipeline and you have this linear stuff figured out, then you know how many buffers you need to allocate in the beginning, or hopefully to actually run it. But then you add another branch, and that may sit on the buffer for a long time for whatever reasons, right? So basically, you grab this buffer and then return it for some time. And suddenly there's a buffer missing, so you need to allocate a new one. At the beginning, this was like, I know what's the maximum I might need if I add all the parts of my pipeline, so I increased the minimum buffer size. Hard-coded patch there somewhere. I think I set it to 10 buffers for the camera to create so that everything worked. Not nice. But then the Video for Linux guys created this great new API, the create bus IO control. So I can actually create new buffers. And so I changed the Video for Linux GStreamer code to actually create a new buffer with this as needed. That works pretty well. Then reconfigurations. If you change a pipeline, add something to a T, then in all likelihood the source will get a reconfigure event and try to change its caps. Or probably figure out the caps are the same, but still try to set the caps. And the Video for Linux plugin decided to, oh, I need to change my caps. So I need to shut down my pipeline because I cannot change my configuration while I'm still streaming. So I tried to stop streaming, and it didn't work. Because there were buffers somewhere, and I was waiting for buffers, and it got stuck there. So what I did was actually change the code to be more intelligent to see if it actually needed to do something when the new caps came around. So if the caps were the same, because I mean the camera is pretty limited there, we have the full HD camera, the video format stayed the same, the frame rate stayed the same, there's nothing to change. So basically added just code to not do anything if the caps didn't change. There was also an issue if you actually did need to change. this is mostly here. If you look back here at the pipeline, the scaler in the lower part. If I switch from the file decoding to the streaming, the scaler needs to switch its configuration maybe from one size to another. That can work, but when stopping, it needed to return all buffers to the kernel and release them there, because otherwise the kernel said, hey, there are buffers around with this configuration. I can't change this right now. That was missing there as well. That was something I had to fix. Yeah, and handling encoded buffers it's not really about dynamic pipelines, but it was there as well. I mean, encoded buffers don't really show, or rarely show up in video for Linux. Just in the camera, maybe, if it's a USB camera providing an encoded stream. But otherwise, especially for an output, nobody ever had an output with encoded buffers, and there were some issues setting the buffer size and things like that. Then there's property handling. GStreamer video for Linux devices can have a lot of properties. And especially if you look at an encoder, there are a lot of tuning knobs you can turn to change the amount of data it's created, how long it takes, etc. And in Video for Linux, you can only set those properties when your device is already opened. In some ugly cases, actually, after it's configured. But anyway, in GStreamer itself, the properties are set when you set the properties. So basically what happened is, property gets set. Oh, the device is not open. Ignore it. And then the device was opened, and the properties change got lost. Also, there are a lot of new properties. I didn't want to map all those to individual GObject properties, so we basically put in a GST structure there that can contain all the properties we like, and it gets set after the device is opened. Yeah, correct Video for Linux shutdown. If you just use a GST launch pipeline, you don't care, because it's just at the end, and everything is just deleted, right? But if you dynamically change your pipeline, especially if the buffer is elsewhere occupied, it happened that, oh, I shut down my element, okay, I stopped the pool, I stopped my element, okay, delete the element, done. And then the buffer was released somewhere else. The pool was still around because the buffer had the reference to the pool, but the element was gone, and yeah, crash. Things like that. A few race conditions there as well. But nowadays, I don't have any issues there at all anymore with the video part of the pipeline. So these kind of things work pretty well right now. Changing the pipeline, not an issue. Smooth, works all the time. The only thing that gets stuck, that's typically audio related. But that's a different issue. So that's how it looks like. So I changed, basically it's a dot file generated from GStreamer. I changed it a bit. It's top down, so it better fits on the slide. And I modified the colors of all elements that are actually Video for Linux. So here on the left side, you can mostly ignore that. That's audio. Then here in the middle of the top, on the top, that's playing. I think it's from the stream, so it gets split up. Left side is the audio. Right side, the red block. That's actually the decoder. And then there's the scaler, and the one here at the bottom. Where am I? Here. That's the output. So that goes to the display. Here's the camera. And we have here multiple variations. This is here with the red. That's the UVC sync for the USB. And the others are just snapshots. And here it goes encoding for streaming, the audio path here at the side, and the network stuff. This is all the RTP stuff. So this is the pipeline, the complete pipeline, or one snapshot. I mean, it can change all the time. So I basically picked a nice looking one here, where there's interesting stuff in there. So this is the full pipeline running. And in this case, I think it used about 30 to 40% CPU load. But that's audio. There's somewhere audio, I think some audio converters and maybe even rate converter in there, and there's a adder somewhere. If I remove all the audio, we're less than 10% CPU load, probably less than 5. It's difficult to tell at that point. But the memory bandwidth is absolutely at the limit. You really see that, because if I look at the audio and I have this adder in there somewhere, and typically, normally, it's way fast. So it could do like 10 times the amount of data it could add. So way fast, no problem. And then I add all these video parts, nothing on the CPU, but the scaler works, reads memory, writes memory. The encoder, the decoders do stuff. And at some point, suddenly, the adder is slowed so much that it actually slower than needed, because it just can't get the memory. So we're really, really getting at the absolute limit of what the memory can provide, memory bandwidth of this hog. And GStreamer is still, yeah, sitting around, basically handling a few buffers, but never actually running into any issues. So this is really great. We have GStreamer basically doing the maintenance stuff, not providing any limits here, but enabling us to use all this hardware to provide this, I think, pretty cool setup there. Yeah. And yeah, what's next? I'd like to get more things into the mainline. And I mean, we heard from the last talk, this developing on an island and sitting there having the plugin somewhere. I hope that my code won't end up like that. So the small stuff is already mainline. A lot of bug fixes for the core video for Linux parts. Bug fixes elsewhere, the DMA buff stuff, it's already in 1.2. But the big two parts for the mem-to-mem device and for the zero copy parts, that's still sitting in my Git trees, mostly because I need to clean it up. Yeah, make things more robust. Yeah, the problem is if you don't know what you're doing, it's not too uncommon that the pipeline just gets stuck. And you don't know how, you don't know why, or it's just it won't start at all. And it's not quite easy to see why there's a problem. It's better than it has been in the past, but I'd like to improve that a bit more. Yeah, the dynamic pipelines, I can reconfigure some things, but yeah, Video for Linux doesn't make it easy because I need to return all the buffers. I think we heard that yesterday at some point, that sometimes it's necessary to return the buffers, wait for that, and then you can reconfigure. That's the case here, and yeah. At some point, that won't really work correctly, especially if you have something like, I have a scaler, and at the output side, there is a display. And the display won't return the last buffer because it's showing this last buffer. It's queued in hardware. And I want to reconfigure, so I wait for that buffer, and I wait forever because I won't get the buffer back unless I shut down the display element, the output element. So issues there. I'm not sure if we can actually fix that correctly. Maybe with some new Video for Linux APIs. I mean, right now, this I need the buffers back before I can reconfigure is actually quite an artificial issue that it's not actually necessary. It's just there because it's easier. I only have one configuration. Otherwise, I would need to basically set the configuration for each buffer. But I mean, that would be possible. So it's just I allocate the buffer with a configuration, and the hardware can figure out, I mean, for example, if it's a scalar, it doesn't matter if the input, what size the input buffer has. It just scales from that size to whatever the size the output buffer has. So you could do anything there, but you would need to be able to allocate buffers with individual configurations and release them at any time. And we're not there yet with Video for Linux. Maybe we'll get there. OK. I think that's it. Questions? I think first question I can answer, the code is there. So if you want to actually look at it, that's where you can find the patch. It's not so nice, but it's there. A difficult question at the beginning, Glad.
Does it work?
Yeah, now it works.
In the beginning, you mentioned that you didn't use base transform and the other base classes. Did you consider to do something similar to the OpenMax plugins, that you have some kind of helper object and then use the video decoder and video encoder base classes? Because, well, in my experience, it's saving you lots of trouble.
I'm considering it. Mostly, I've not really looked into it because, well, historical reasons. When I actually started that plugin, the encoder and decoder didn't exist, and the transform didn't match. So for the encoder and decoder, it might be possible, yes. I mean, we already have helper objects, basically, for Video for Linux. Maybe I need another one. I don't know yet. So it might be possible to actually use the video encoder and decoder. But we still need to write a, well, asynchronous base transform, basically, to handle the scalar case.
I think that's something we need sooner or later anyway.
True,
some kind of base transform too.
Yeah, that's definitely a base class. And once we get in that direction and figuring out which code goes there and which code actually is Video for Linux specific, then we can definitely look into using the base encoder and base decoder, video encoder and video decoder classes. Yeah, but they're newer than the initial code, and yeah, you know how it is. It works, so nobody pays. But that's where I want to go. I'd like to start with the transform, actually, because I think splitting out the things there makes it clearer what goes where. And also, I don't have to maintain two plugins because I can't abandon the scalar and just write the encoder. So I think if I find the time to do that, this is probably where I would start.
OK, if you need help with that, ask me.
Yeah, definitely. Any other questions?
You have one filter element which can do a lot of different things, right? Yeah,
right now, yes. There are limitations, which is why he suggested to do the video encoder and decoder stuff.
Yeah.
I'm sure it will help for all the advanced features, but what we have right now works quite well for the basic stuff.
Yeah. My question was, have you considered using the approach of the FFmpeg plugins, where you have basically a template which is instantiated for different codecs?
I don't think that's possible, because the differences are actually that I mean, the common code is that what I have in the base core anyway. This is the Video for Linux buffer pool and a Video for Linux object. So the rest is probably where I need to use not one template, but the appropriate base for that use case. Because if you look at FFmpeg, it's all encoders, but different backends. And I have one backend and different APIs to the front. So it's actually the reverse case, basically, to what FFmpeg is doing. But I don't know the details from the FFmpeg code, so I can't really comment on that there.
Any more questions?
Yeah, well, I think 1 minute left or something like that. So one last question. OK. So thank you. And